RFD 900 Plus radio configuration. This video is made in part of a video series for the Eclipse ballooning project. The scope of this video may seem very narrow. That is the intent. We do not intend this to be an all-inclusive user's guide for the RFD 900 radios. We're just going to be going over the one application of using this radio to stream our still image pictures from the payload to the ground station. Now, the ground station computer provided already has all the drivers and necessary software to configure the radio and use it with the ground station. Once this configuration is done for the first time, you do not need to repeat it. We do the configuration once and on 2 radios, and those 2 radios will be ready to be installed in the payload. In the event that you are using this radio within the vicinity of other ballooning groups with similar settings on the radio, we will need to make a couple other settings to prevent crosstalk and interference between the 2 groups or several groups, and this will be covered in a different video. This video will be going over the basic settings to get the 2 radios talking to each other to be installed in the payloads. Now, lots of information can be found on this radio at RFD's website. You can search RF Design, RFD 900 Plus. What we're looking for is this product page at RF Design's website on the RFD 900 Plus modem. From here you can find documentation, data sheets, and lots of other information. What we're using is the RFD 900 configuration tool, modem tools. In RFD tools, version 1.5 is what is installed on the ground station computer. We have used versions 1.3 through 1.5 with no problem, and they are sufficient for our needs. 1.6 has been kind of buggy and unstable. Therefore, that's why we're sticking with version 1.5 or earlier. You will also be using the FTDI cable. It's a little 1x6 header on one side, USB-B male connector on the other side. This is the same cable that is used to connect the ground station antenna tracker to the ground station computer. It already has the drivers installed, but if you want to install them on another computer or just curious and want further info, you can search FTDI drivers. And what we're using is a virtual COM port drivers. Some other helpful information can also be found at SparkFun. They have a tutorial on how to install the drivers. It's pretty straightforward. Go to their page, select your architecture, operating system, download it, and this will download an installer to install the drivers. The drivers and the cable are needed since the radio and the Raspberry Pi are communicating with each other over RS-232 serial. Most computers, newer computers anyways, don't have serial ports, so this is basically emulating a serial port so that we can communicate with the radio and set the settings on the radio. Then we need to know what the COM port number is of the FTDI cable. If you just go to your device manager, under device manager and ports, this will give you a list of all your COM ports. Now, there'll be a COM port assigned to your FTDI cable. On the ground station computer, more than likely you'll just have one entry here. Now, you do need to have the FTDI cable plugged into your computer in order to see this. So go ahead and plug your FTDI cable into the ground station computer. Just search device manager, and that will bring you here. And under ports, you'll have a USB serial port with the COM number assigned to it. More than likely you'll just have one entry. In my case, I've got a couple of different COM ports on this computer. The one I'm using for this cable now with this radio is COM4. Now, this number won't ever change. As long as you're using the same computer with the same FTDI cable, this COM port number will stay the same. Once you look it up once and remember it, that's the COM port you stick with. You can use other cables. You'll just have to go back into the device manager and look up to see what COM port number it was assigned. Also, on the ground station computer, you'll have a folder that has some RFD utilities and a couple of references. There's the FTDI pinout for the FTDI cable. So on the cable itself, the top black wire is this top black wire in the diagram, number 1, which is our ground. Also on the RFD user's guide on the product page, you'll find the same diagram. This number 1 on the diagram, this is the pinout of the header on the bottom of the radio. So this 2-row header that is on the bottom of the radio is this pinout here. So number 1 on the bottom left, which is ground, is also this bottom left pin on the header. So you can see the 2 rows of the header here. Camera will focus. There's 2 rows here. This bottom left one is ground. On the top there's a little jumper. This jumper is going between pins 4 and 6, which is needed to bring power from the FTDI cable to the radio. Now before we connect the cable to the radio, we want to make sure we have the antennas attached. As soon as the radio powers up, it'll be trying to find other radios in the area and it will be transmitting. So whenever a radio is transmitting, it's expecting a certain amount of impedance on the output. Now per RFD's website and their data sheet, they say that 1 antenna is good enough. Good habit, good practice. I suggest putting an antenna on any output on any transmitter. Because when it transmits and it's expecting a certain amount of impedance, if there's no antenna there and there's no impedance there, you can send too much power through the finals of the radio and you can damage the radio. So before powering the radio, always make sure you have an antenna connected to the output. You can use any antenna provided in the kit. These little quarter wave omnidirectional antennas are just the most convenient. You can use the longer half wave or even the Yagi or patch antennas on the ground station. But for sake of demonstration and convenience, I'm just using little quarter wave omnidirectional antennas. Once you have the antennas attached, you can go ahead and connect your black number 1 of the cable to your bottom left number 1 on the header pin. So you're using the bottom left 6 pins of the radio header. Now once you have the radio connected and you know which COM port your FTDI cable is on, you can now go into the RFD utility and set the settings on the radio. So in the same folder with the pinouts and the RFD information, there's also a screenshot of the settings that we want. You can use this for your reference. These are the settings that we want to set on the radio. So using the modem tools, this is the utility that we use to set all the settings on the RFD 900. Now you want to select the COM port that you found out previously in the device manager and select read settings. And what this will do, will read the current settings on the radio and display them here in the user's interface. Now default, the baud rate is set at 57,600. This is the data rate that the radio communicates with the computer. Now this radio that I'm using here, I've already set this up. I've already configured it to be used on the ground station and the payload. So it'll fail to connect here. So as soon as we get this failure notice, say failed to load settings. Now anytime you get this error, 99.9% of the time it's because you have a baud rate mismatch. Now when your very initial setting of the radio from the factory, it is set at 57,600. So if you've never configured a radio before, you will leave this setting at 57,600 and read the settings. If you've changed the baud rate at any time, you'll have to match the baud rate with what it was set at. So in our case, I've already configured this radio in the past, which we're using 38,400, and read settings. Now if it's successful at reading the settings, It'll tell you upload or something like that successful. And all of your settings, settings loaded. So all of these values here are the current values of what the radio is set at. Now these are the values that we want. This is the values that we want on the payload side and the ground station side. So our baud rate will always be at 38,400. Airspeed is at 48. You can go to 64. This can decrease or increase the amount of time it takes to download a picture. Right now the pictures are being sent in 10,000 bit packets. If you get any error in there, it'll resend that packet. If you increase the airspeed, this is the speed, the data rate the two radios are talking to each other, you can get more bit errors, which will result in more packets needing to be resent, which can make downloading the picture take longer. What we found is 48 for the airspeed to kind of be the sweet spot of not taking forever to download a picture, but it is also not incurring a bunch of bit errors to where we got to resend a bunch of packets. Now the net ID, this is just an arbitrary number that you can select. Just make sure both radios that you're using, payload and ground station side, have the same net ID. This is basically like a network name, like an SSID name on Wi-Fi. So all the radios, if there's any other radios nearby, if they will all receive all packets. If it's intended for a different net ID, the radio will just ignore that packet. If it is intended for the same net ID, then the radio will listen to that packet. In the future video, I'll be going into the settings on net ID and min-max frequency if you're using the radios nearby other groups that are using the same radio. TX power, 30 is the maximum. We want to set it to max. This is the RF transmit power of the radio. 30 is equivalent to a 1 watt transmit power. These other settings you can't set. You don't need to worry about those. Node ID, node destination, node count. Error correction, uncheck. Mavlink, we're not using uncheck. This error correction, the RFD 900 Plus changed something going from the 900 to the 900 Plus, where they kind of limit the packet size and change the way the serial buffer works. And this messes with our error correction. We have our own error correction, so we do not need this checked. Our error correction takes care of all of that on the Pi and the ground station side. Op resend, leave this selected. Ready to send, continue to send is not being used. Leave that unselected. Once all your settings here look the same, you go ahead and hit Write Settings. And that will take all the values here and write them to the radio. Once you get this AT_W, that means it successfully wrote in it OK. That means it successfully wrote these settings to the radio. Now your radio is ready to be installed in the payload and used with the still image system. You'll do this twice. You got two radios, one for the payload, one for the ground station. Set these settings the same on both radios, and they're ready to be used on the payload and ground station. Thanks for watching.